All right, guys, I hope everybody's ready to go. I got my whiteboard and my marker, just like I asked you guys to have. I'm going to ask you a couple questions, and they pertain to what we learned yesterday, okay? Now, listen, if you get them incorrect, it's okay. We just want to try to start getting our brain working a little bit in this water cycle environment. So, first things first, other than water, what must be present in order for the water cycle to work? And I'll give you a big tip. It's a star. So write that down. And when you're ready, go ahead and pop those up. All right. If you put down the sun, then you are correct. Remember, the sun's not like an engine in your car, but it is the engine for the earth. It makes everything run. It makes the water cycle run, makes the plants grow, makes the oceans flow. All right, clear board. I got another question for you. There are two ways that water can be evaporated from the surface of the earth. Just write down one thing that evaporates water. And I'm gonna write down both, just in case you write down one or the other. All right, when you're done, you can hold those up. I see some good answers. The sun and the wind are the two ways water is evaporated from the surface of the earth. Okay, now the sun is the main one because remember, and y'all are gonna learn this in a few weeks, the sun makes the wind. And I know you're like, how does that happen? I'm gonna tell you in a couple of weeks how that works. But the sun makes the wind, so without the sun, there would be no wind to evaporate either. So you got to remember that. All right, now, here's the next one. What does hot air want to do all the time? Does it want to rise or does it want to fall? Write that down for me. What does hot air always want to do? Awesome. It wants to rise, okay? Now, if that's the case, then what does cold air want to do? Cold air wants to fall, okay? And today I'm going to go over something that's a little confusing with that statement I just said, because it's going to confuse you a little bit, but I'm going to try to walk you through it, okay? All right. We're going to go ahead and get started, because I got a lot to talk about. Miss Moore, is there any way you could make my screen so that I can only see myself? Is there any possible way to do that? Miss Moore, you're muted.
You're going to have to hit speaker view, Mr. Allen, but you're going to have to go to your screen.
Uh-oh.
And boys and girls, if you'll actually hit speaker view, you'll be able to adjust it, Mr. Allen, as well, which will be a better.
Oh, well, I can't do that. Okay, so the first thing I want to go over, huh? I'm just going to do it from here. It's fine. Can everybody see this screen? Can everybody see it? Give me a thumbs up if you can see it clearly. You can read the words and everything. All right, great. Okay, so yesterday we went over evaporation, all right? And I know that maybe some of you might still be a little bit confused about it, and that's fine, all right? We'll get through it. But the next thing I want to start talking about is the next step, all right? And the next step is going to be condensation. But I'm going to give you some examples of condensation before we move on and we start drawing the picture. Now, when condensation happens, and you guys, you make condensation every single day in your house, and you probably don't even realize it. And I'm going to give you some examples. The first example is going to be this one. How many of you guys have ever gone out on a cold day and you act like you're smoking with a paper cigarette? You ever do that before and you blow smoke out and you think you're all grown up? Yeah, I think some of y'all do that. I did that a lot when I was a kid, acted like I was a train blowing smoke. Well, that's condensation. And let me show you a picture of what happens. All right, uh-oh, excuse me. So this guy right here, I do not know who this gentleman is. He is not smoking and he is not vaping. He is outside on a really cold day, all right? So let's talk about why this cloud is happening. And it kind of will give you an overview of how clouds are made in the atmosphere, okay? What is the temperature inside your mouth? Do you think it's hot or do you think it's cold? I hope all of you said that it's hot because you are a human being and your average temperature is 98.3 degrees, which is hot, kind of like a hot day here. That's about how hot your body is. Well, when it's cold outside and you breathe hot air into the cold air, it causes a reaction and it causes this condensation to start to form. Because remember yesterday when I talked about hot air and cold air and how they didn't really get along? Well, this is the reaction of the hot and the cold air mixing. All right, so that's just one example. All right, so in the winter, you guys could do this all the time. You go outside on a cold day and you can blow smoke. It's really condensation. All right, let me give you another example. All right, how many of you guys have ever walked out on a summer day or summer morning and all the grass is super wet, even though it hasn't rained? Yeah, it happens all the time, and it happens because the sun heats up the earth all day long, and then at night when the sun goes down, all that heat gets released and it gets cold and it makes water form. That's a form of condensation. You guys probably experience that quite a lot if you go outside early in the morning. All right, this next one's a little bit better. This one right here is probably one you experience quite often. You go to the refrigerator's cold, you pull a nice cold drink out and you set it on the counter or you set it on your wooden table or your coffee table at home, and what does the drink start to do? It starts to sweat. And the reason that's happening is because that drink is cold and the surrounding temperature is hot. So it causes things to start sweating. All right, let's do one more. I'll show you a couple more. Okay, here's a really good one. How many of you guys have ever seen a jet in the air and it looks like it's on fire in the back? Any of you guys ever looked up in the sky and seen that before? I hope so. I see that all the time. Well, this is another form of condensation, all right? And this is a real life condensation. That is a huge jet, a 737, 747, one of those gigantic jets that take people places. And do you notice that coming out of the back, it looks like smoke? And you might say to yourself, whoa, that plane's on fire. And it's not really on fire. It is a reaction from hot and the cold. Now, this is gonna trip you up a little bit, and I don't mean to confuse you, but when a jet gets up that high in the air, and that's probably like 6 or 7 miles up in the air, it gets really, really cold when you get up real, real high because the atmosphere gets really thin and it can't support oxygen. Now, I did tell you yesterday that hot air rises, but it only goes up a few thousand feet and then the atmosphere gets really thin. So this is a reaction of hot and cold as well. Do you think those jet engines are hot? Yes, they're as hot as your parents' car engine when they start driving. Now, the reason you don't see smoke coming out of your parents' engine is because the heat of the engine is the same as the heat outside. But this right here is a perfect combination of hot and cold. You got super duper hot jet engines pushing out heat out of the back, and it's reacting with the cold and it's making a cloud form. Okay? So these are all examples of condensation, hot and cold mixing. Okay? I might have one more picture. Look, these right here, have y'all ever seen those before? Those that look like big long Twizzlers through the sky that are white. Those are contrails, and those are what happens when the jets go through. And sometimes they disappear, sometimes they don't. These guys right here, they can actually get caught up in real clouds. They can actually become part of weather systems if the conditions are favorable and the wind doesn't blow them away or they just don't evaporate. But conditions have to be perfect, okay? So I hope that helps you understand what I'm going to talk about today, because we're going to talk about hot and cold mixing today. And that's how condensation happens, okay? So, let me see. I might have one more. Oh, I want to show you this. Can y'all see that mountain? Can y'all see that? Y'all can't see that? I know it's kind of, let me see if I can get it better. How about this one? You see this one a little better? Okay, this one looks a little better. So, that's an odd looking picture, don't you think? I mean, there's snow on top of that mountain, but there's no snow all through these beautiful green fields. And why do you think that is? And no, I don't expect you to know. I'm just kind of letting you guess. Alana, tell me, girl.
Because it's colder up there.
Yeah, perfect. This is called the snow line, okay? And when you get really high up into the atmosphere, obviously we don't have these big mountains in North Carolina, but if you go somewhere where there's a giant mountain over 10 or 15,000 feet, it gets so cold up there that snow, no matter how much the sun shines on it, it's not gonna melt. It's so cold way up in the atmosphere that it won't melt. So I'm kind of like going against what I told you yesterday with hot air rising. There's a point where it kind of stops, and then all of a sudden it gets really cold because you're getting closer to space. All right? What, Miss Moore?
Logan has a question.
Who? Logan?
Has a question for you.
Logan.
No, I was gonna answer that question about how cold it is in the air.
I'm sorry, bud. Does anybody else have a question? Noah? You got a question, Noah? Okay, anybody else? Okay.
Just real quick, guys, please do not chat each other. You need to really be paying attention to Mr. Allen.
Yeah,
The chat.
you certainly do, because I'm giving you guys a test next week. So you guys need to pay attention.
Yeah, if I don't do this correctly, then we'll just make the chat just to teachers.
All right. So that's going to take me into my lesson. I hope it works. All right, here we go. Now this looks probably something like I did yesterday. All right, I drew a picture of the water cycle, and this is when I'm going to give you the explanation of why these things happen. Okay, so here in the beginning, obviously I have the most important thing up there, which is the engine that runs the earth. You got the sun up there, and then this is going to be the magical little line of cold right here. All right, and you can see, because I drew a little airplane up there to try to make you guys understand that that's the cold line. Okay, so when I told you yesterday, you have a body of water, you have land, and you need the sun or the wind to start this evaporation. Now remember, when the sun beats down on water, it's going to turn it into a vapor. You cannot see the vapor. The vapor is super light and it's heated up, so it starts to go up. That's why I have these arrows pointing up. Well, it only goes up so far. So once it gets up to this little part, it runs into a problem, because this hot, heated up vapor meets cold air. And it's going to do the same exact thing I just showed you with those pictures. Okay, but there is one little thing that it does. Way high up here in the atmosphere, there is tons and tons and tons and tons of dust. And this dust gets put up in the atmosphere by a couple of different things. There's sandstorms that can put dust up there, and also smoke from fires goes up into the atmosphere and it settles up there, and there's tons of dust in this smoke. So it's got tons of stuff to hold on to. So up here, these little dots are going to be my specks of dust. So once this vapor goes up, and it's a vapor, it's not a liquid, it's a vapor. Once this vapor goes up, it hits that cold line, and this hot and cold react. And when that hot vapor hits that cold air, it turns from a vapor back into a liquid, and they start to touch one another, and these vapor droplets start to touch, and they start to gather on these specks of dust. And here's a cool little thing for you to always know. Inside of every single raindrop, there is one speck of dust. But don't go try and find it, because it'd probably be pretty tough to find that speck of dust in one raindrop. but there is, because the vapor has got to hold on to something. So once it starts to gather and the liquid water starts forming, then what do you think starts forming when this reaction happens? What is it, Faith? What do you think? Oh, she went blank on us.
I think it probably will start a storm or something.
Well, yeah, clouds start to be made. Okay, so when this warm vapor goes up and hits cold air, clouds start to form. Okay, and this is condensation. Now, I don't want you guys to get confused when I talked about the hot air rising, because remember, when you hit that line, it's going to be cold. And that's why when you go on an airplane, if any of you guys have ever been on an airplane, it has got oxygen pumped into that airplane because there's no oxygen up there. It's extremely frigid. So that's where all the clouds form. And once these clouds get large and they get really big and they get super heavy, they dump their precipitation, okay? And that's what's gonna cause the precipitation to fall. Now, I'm not gonna go any further today because this is a confusing part of the water cycle, but these two right here are gonna be your toughest parts, okay? The other four parts are very, very easy. So if you can get these two parts down today, you'll be in great shape. Now, do any of you guys have any questions? Nobody has any questions? Yes, Logan.
How is it cold up there if all the cold air goes down?
Well, the reason it's cold up there is because the higher up you go, the atmosphere gets really, really thin. So if we tried to go up at the top of that mountain that had all that snow on it, we wouldn't be able to breathe very well. It would be kind of like an elephant sitting on your chest when you tried to breathe because the air is really, really thin. And if you guys have ever watched anything on Mount Everest or anything like that, and you see some of those guys climbing those mountains with those oxygen masks on, they're wearing that oxygen mask because there is no oxygen at that elevation. We haven't gone over the atmosphere yet, but we will. The atmosphere gets super thin, and you just can't breathe up there at all. It gets cold. There's hardly any wind. There's nothing going on up there. It's totally still because you're starting to get up into the stratosphere, and we live in the troposphere, which we'll get to that one day soon. But that's a good question. It's kind of, that's why I'm telling you not to get confused with what I'm trying to talk to you about, because hot air does go up, but there's a point where it just can't go up any further. All right? And I know it's confusing. I know it is. Anybody else got a question? Nobody?
Wait.
Yeah, what's up, Noah?
I just have one little question. I've heard from like friends, and I kind of believe it. If you go too high, you can freeze.
Oh man, you can freeze. That's why that snow's on top of those mountains, is because it's so cold it can't melt. So if you go up to like 30,000 feet, which is about where those jets fly, where those contrails are coming out, it's probably about 50 to 60 degrees below zero, at least. And so that's why they don't want people getting on planes and stowing away in the luggage, because if you do, when you land, you're going to be a popsicle. It's so cold. It's so cold up there. Yeah, Logan.
The particles that are up in the cold air, aren't they cold as well?
Yeah, they're cold as well. I mean, it's just dust. And you got to think, Logan, that dust is super duper small. And, you know, there's so much dust in the atmosphere. You know, it falls on our cars. Some of it comes off of us. We got a lot of dust coming off of us. It's dead skin. So some of that could be up in the atmosphere as well. There's a lot of dust up in the atmosphere, a whole lot. Aiden Michael, what's your question, bud?
Wait, so could some of the dust particles in the clouds also form snowflakes?
Well, snow is basically formed, it has to do with the air temperature outside and going up to the atmosphere. Obviously, it's way too warm to snow right now. That's why we always get snow in the winter, is because the air all around us is cold. So it's not necessarily going to develop snow, but it could develop hail. And we're going to talk about hail. Hail comes out of massive thunderstorms, and it's those little bits of ice. And we're going to talk about how that forms, because it kind of goes against the snow thing, because hail forms. It's really strange how hail forms, but you got to have a lot of wind. You got to have a lot of instability in the air, and we'll get into all those words later. Noah, what's your question, bud?
I just have one more. How does the dust get up there?
It gets blown up there. See, so we don't have a lot of deserts around here, but deserts, when they have a lot of wind blow over them, they can make massive dust storms. And I'm talking about dust storms that are, you can't see your hand in front of your face. They're so bad. A lot of dust gets put up like that. And also, Noah, if people are burning trash, burning wood, forest fires catch on fire, that smoke has a lot of dust in it as well. So the wind throws that dust up, the smoke can do it. There's a lot of ways dust can get up into the atmosphere, bud.
Cool.
All right? So does anybody have any more questions? You guys are doing a great job. Fatima, are you asleep, girl? I hope I'm not boring you to death. So listen, give me about 30 minutes. Let me try to get this video up, and I'll give you 5 more questions. And I've looked over your stuff. And most of you guys are doing such an amazing job. If you haven't done that work, make sure you're going and getting it finished, because we're going to start taking these grades. And it's important for you to know this. I promise you, it'll really help you for the weather when we start going over it, to understand why clouds form and why evaporation happens. So just make sure that if you got to go back and look at this video again, you do it. Okay, because everything's not going to be this difficult. There's going to be some things that you get really quickly, and then there's going to be some things that are going to give you a really hard time. Okay? So are there any more questions? I can't see the second page. Let me see. All right. If there are no more questions, people, remember, you can always send me a text on Google Classroom. Your mom or your dad can send me something through Talking Points if you have a question about anything, okay? But if you can get these 2 steps down, you'll be in great shape. If you can get evaporation and condensation down, then the rest of it is really, really easy, okay?
Hold on. Mr. Allen,
Yes, ma'am.
whenever I was trying to do the whiteboard thing with you,
Mm-hmm.
my whiteboard marker, it was dried out.
It's okay, girl. If you need another one, you can come by school and we can get you some, okay?
I'll just write on the paper.
You're good, girl. Don't worry about it. I'm glad you're listening, though. So listen, if you are going and you're doing the Ed puzzle for me and Mr. Murphy, and your score does not pop up, you do not see your score, I want you guys to take a picture of it and send it to us so that you can prove to us that you did the work. Some of you guys, I've called you and y'all are claiming that you've done the work, and I asked you to send me a picture of your grade and y'all never did. So some of you guys are having trouble. You're going in and doing it and the grade's not popping up, and then you got to go back and do it again. We want to make sure we address all that, because we don't want you having to do things twice. So if you don't see your grade on Ed Puzzle, please let us know, okay? I had one parent reach out to me, and we got her son all situated. Hopefully it's going to work better today, but just like I said, it's new for us. It's new for you. Just, we'll figure it out. All right? Does anybody need anything else? All right, so listen, thank you for listening, and I hope that you go back and do these questions, and let's try to make 100. Remember, all the answers are going to be in the video, guys, so make sure you go back and rewatch it if you're not sure about something. Especially if your parents are listening, maybe they can help you out a little bit, So y'all have a good day, and we'll talk to you on Monday, all right? I'll be expecting to see your work later on today. Give me about 30 minutes, okay? Okay, guys.
Bye.
Y'all have a good one. We'll see you at 12, okay?